All right, so thought I'd start off with a little bit of encouraging advice. I know sometimes it feels like you're all alone, especially in the lockdown. But just so you know, there are some things that are always there for you. So just thought I'd share that with you as a bit of encouragement. We're going to be taking a look at these two functions here, and then we'll take a look at what those graphs will be and kind of going through the process that we want to do. We're going to keep this pretty quick and simple. And hit the highlights and then worry about everything else later. But so here's, it's the KISS method. Keep it simple, silly. So if you haven't heard that one before, this is, so KISS. So keep it simple, silly. Okay, that's how that works. Keep it simple, silly. Okay, so now, in this particular case, what we're going to do is we're going to be looking at some different things. And so in this case, it says apply the leading coefficient test. All right, so basically we look here and we say, hey, our leading coefficient test is, well, that's a positive. So it's a positive 1, which means that as x goes to infinity, where is y going to? So for A, x goes to infinity, y is going to infinity because it's positive. All right, now take a look at the degree. So as x goes to negative infinity, where's y going to? Y is going to positive infinity because we have an even degree. Even degree, these are the same. Odd degree, these are opposites. So I talked about that. Okay, now we want to find the zeros. Okay, so we're going to find the zeros, so B. So then what we're going to do is we're going to use factoring. And these are all going to be ones that we can factor simply. I thought it'd be a good idea to start with ones that we could factor simply, and then later on we'll move to more challenging ones when we get to them. But so I thought, let's take it slow this year. Let's take it slow because we got it's a messy year. But so if we start off with that x to the fourth minus 4x squared, well, both terms have x's in them, so we can factor out an x squared. That'll leave x squared minus 4. And then, of course, that right there we can factor as x squared times x minus 2 and x plus 2. Pretty cool, huh? Okay, I think so. All right, so what this means is then we'd have x equals 2, x equals negative 2, and then this one is going to produce x equals 0, but a multiplicity of 2. Okay? So these ones just have 1. Now, the thing about a multiplicity is this going to tell us how the graph, what happens at the x-axis. So whatever this is going to tell you the degree the graph is going to behave like. 1 degree are going to behave like lines. It's going to behave like a linear function. A second degree is going to behave like a parabola. So what's going to happen then, and it says plot sufficient points. Well, the only sufficient points that we really need, take this, okay, read intercepts. That's what we're looking for. X-intercepts and Y-intercept. What's our Y-intercept? 0, 0. So that's nice. Okay, so we got 0, 0. And we have negative 2. And we have positive 2. So those are the sufficient points we need. We know that on the right side, the graph is going to be pointing up. We know on the left side, the graph is going to be pointing up from this is what this means, right points up, left points up. So both sides are pointing up. So I'm just going to do that. All right, and so then there's 0. All right, so it's going to go through. And here's the thing, like this, okay? These ones, multiplicity of 1. So these two are going to go through like a line. Now, I know that I remember hearing your discussions that, and so you guys know, that, what that looks like, okay? Because, the odd ones go through it, which is great that you know that. So these are going to go through like a line on both sides. But now we have this. This is produce that issue, okay? So this one right here is going to look like a parabola. And I know that Miss Trujillo did a good job because I heard those discussions, and so you guys know that it bounces off or something like that. So it's going to look right here, because these are both down here. Well, it's got to be, it's continuous, so it's got to be, the parabola is going to be down here. So we just make like a little tiny parabola, not the whole thing, and then we just want to connect it all, so that way it's smooth and curvy. Remember, no sharp teeth, no sharp teeth. Okay, don't scare Littlefoot. So, like so, and it makes a nice curvy W. And this is what I'm looking for. Now, if you want to go check it on Desmos, Desmos looks like this. And I would say that, hey, I am happy with this. If you drew this, I'd be happy with it. Well, except for let's put, with X and Y, obviously. So label those axes. So, yeah. All right. So let's take, now let's take a look at the other one. So this one, I think you guys probably should be actually pretty good at factoring this, because based off of the method of using that X factor, I think a lot of you guys are actually going to be already set for factoring these, and you would say, hey, let's group these together and let's group those together. And both of these we have an X cubed, so we can factor out an X cubed there. Then we have, well, that's going to be X squared minus X squared minus 4, sorry. And then over here we'd have plus, well, both of these have an 8, so we have factor out an 8, and then we have X squared minus 4. Okay, and then that factors to X cubed plus 8 and X squared minus 4. Now the difference in sum of cubes thing. So here's a special note. Put this up here, special note. Okay. X cubed plus a cubed, and a could be any number. In this case, is a cubed is 8, so a is 2. A is 2 because 2 cubed is 8. Or we could also have x cubed minus a cubed. All right, this is going to factor a certain way. This part over here is not going to produce any x-intercepts because it's not going to produce any real solutions. But the way it works, it goes x and a, no matter what, x and a, then it's x squared, ax, and a squared. That's how it goes. All right, so it's just a pattern. And then we'll apply this to here. The way it works out is it goes same. So whatever the sign is, it stays the same. So same. The next one is different. So that's plus, we have to do the different one. This is negative, we do the positive. So same, different, then always at the end, always positive. Okay, so just something there. So in our case, we're talking about that top one because it's plus, so it's going to be x. Remember, a was 2 because a cubed is 8, 2 cubed is 8. And then we have x squared, 2x, and a squared, 2 squared is 4. So we put 4. Plus, same, different, positive. Then over here we have x squared minus 4. That factors to x plus 2, x minus 2. That's how that factors. All right, so now, again, this one produces no zeros, just so you know. But we have x plus 2 squared. We have x squared minus 2x plus 4 and x minus 2. So we have x equals negative 2 with a multiplicity of 2. And then we have x equals 2, multiplicity of 1, which we don't write. This is going to look like parabola. It's going to look like a line. All right. But A said, okay, what's, as we care about as x approaches infinity and x approaches negative things, so we care about that end behavior. Y will approach. Okay, so look back up here. So for the first one, as x approaches infinity, y will approach positive infinity because we have a positive leading coefficient. Okay, and then as x approaches negative infinity, y will approach negative infinity because that's an odd, O for odd, O for opposite, so opposite directions. So that's what we mean by opposite. So then when we go to, so B, well, B, this is B, a little bit out of order, whatever. C again, okay, we could also throw in our y-intercept, which is 0, negative 32 from right here. Remember, this tells us our y-intercept. So 0, negative 2, 32, and then we're going to graph it. So that's what D is. Okay, so negative 32, you could just put it like right down here. All right, then we have 2, and we have negative 2. Graph is going to end going down. It's going to, on the left is pointing down, on the right is pointing up. Okay, remember, so if we're down here and we're coming up to this, there's no other x-intercepts, well then it's going to look like a parabola here. And this one's going to look like a straight line. So it's going to come like so, okay? And this one's going to come like so, like this. And then the graph is going to do, I don't know, something like that, okay? Or maybe it's more on that side. But as long as you have the basic idea, then we're okay. So, Isaac, I'm working right now, please. Just wait 2 minutes, okay? So then we can take a look at this, and we can take away that, and take a look at the graph, and you can see it's got that basic idea going on. Again, negative 2 and positive 2, negative 2 like a parabola, positive 2 like a line. And if we zoom out, we can see that it does this, it has like a weird little bend right there. That's what it is. But just gets a little steeper real quick right there. But as long as we got that basic idea going on, if we hit those points, I'm happy. So yeah, so this I'm just going to give you a handful of problems that shouldn't take you too long to be able to finish up in your periods. That way, first and second period will not get past their asynchronous time if they do this, and won't have to worry about any. I'm not going to be, so nothing. So it should be able to get done in your asynchronous time. All right. Any other questions?